Anyway, the sky this month from November the 12th to December the 10th, and it's basically going to be all about the moon, eclipses, high tides, and meetings with planets. So the highlights, there's lunar eclipse, and we'll look at that in some detail. There's some special high tides coming up. And then, of course, there's a number of planets that are showing with the moon. So let's take a look, first of all, at the eclipse. So that's this coming Thursday night. And if you go out at 9:50 p.m., you'll find the moon is in the southeast, and you can see Orion is rising as well. So that's going to become eclipsed this evening. So let's just look at a little bit of terminology. It's going to be a bit of a bright picture. So there's the sun, and the sun kind of radiates light throughout the solar system. But if you put the Earth in the way, then you get this cone of darkness behind the Earth. And the reason why it's a cone is because the sun is so much bigger than the Earth. And so there's a zone where the light from the sun can't get. And then there's also a zone where some, but not all of the light gets. So we call the area where some of the sun has been covered the penumbra, and then the part that's completely dark is the umbra. Now, when I say completely dark, it's not actually true, because the sun's rays, as they strike the atmosphere of the Earth at a glancing blow, they are actually bent by refraction into the umbra. And just as our sunsets are red as the sun sets, well, the umbra is red if you get far enough away from the planet. And that's what happens with the moon. The moon experiences that reddish tinge when it goes through the umbra. So this is the moon as it's just about to enter the penumbra. And so this will be at about 10 p.m. on Thursday, just the first touch. And then the moon will move through the penumbra, and it will do that in about an hour and 20 minutes. So by 11:20, the penumbra covers the moon completely. And I'm not sure, I mean, even if it is a clear night, we can actually see the moon. We may not actually be able to really distinguish the faint effect that the penumbra has in darkening the moon. But almost at the same time, the moon will arrive at the umbra. And that's where we can hope to sort of see the moon or the shadow actually beginning to cross the surface of the moon. So then the moon moves completely into the umbra, and at about 1 a.m., it will reach a maximum. It's not going to actually completely, totally cover the moon. And the reason for that is not because the moon is bigger than the umbra, as my picture shows, but rather that the moon just kind of missed the center of the umbra, is out a little bit farther away towards the edge, and so it doesn't completely get hidden in the umbra. So that's at 1 o'clock. So the umbra starts at 11:20. It reaches its maximum at 1 a.m. And at about that point, you might actually see faint stars that are near the moon visible, because they're not washed out in the bright glow of the moon. So then the moon continues through the rest of the penumbra, and by the 2:50, the umbra is completely gone off of the surface of the moon. So it's taken about 3 hours and 3 hours and 40 minutes or thereabouts or 3.5 hours for the umbra to cross, to sort of start, build to a maximum, and then completely leave the moon. And then one more step, it moves outside the umbra, and that'll be by 4:10 a.m. And you get a gold star if you are there for that event. Okay, so just taking a look now more realistically, here is a picture. That's a simulation from Stellarium. Next to it are those critical times. And we're just going to do a very quick sort of simulation of what will occur. And when I start the simulation, if you're careful, you'll notice kind of a very faint shadow moving from left to right across the moon. And then after a while, it'll become obvious that the umbra is also going across the moon. So you see a very faint shadow just removes almost completely across. And then comes the umbra. Notice it's quite a bit larger in diameter than the moon. And then not quite all the way. And then it clears the moon. And now you'll just see a faint shadow leave the moon. And that's basically the whole show in less than a minute that lasts about 6 hours. Now, I think when I signed in tonight, there was a discussion on, the changing orientation of things in space as we rotate around. And I think one of the things that seems to be very unusual is that the shadow seems to be coming from different points. It's coming from the sort of 10 o'clock position. Now it's more like the midnight position. Now it's kind of like the 2 o'clock position, and it's sort of heading off toward 3 o'clock, 4 o'clock. What's all this rotational jazz? Why is this happening? And it's not because the moon is rotating or anything fancy is going on up there. It's simply because if you imagine it, we're kind of standing on the Earth at an angle to the equator. And as we swing around, that angle changes, the angle changes with respect to the moon. And so we observe what appears to be the rotation of the moon. I'll just do that one more time. Notice that this crater is way up here, and then it seems to be swinging down. And that swinging down is just an artifact of us looking straight up at the moon, but our vantage point is changing as the Earth goes around. Okay, so that is the lunar eclipse on Thursday, and from what I hear from the weather, my simulation is probably the best you're going to do, but we could get lucky. Okay, so now let's move forward to December the 2nd at 7 a.m. in the morning. It's a Thursday morning, so you get up, and if you take a look in the southeast, you'll see Mars and the moon. So Mars is coming out from the glow of the sun, making a kind of a reappearance. So if you have to get out there fairly early, because of course, the later it gets, the brighter the sun gets, the more washed out Mars and the moon will be. It's reasonably low in the sky. That shows a 10-degree distance above the horizon. So you put your fist straight out, and that kind of, you rest the lower part of your fist on the horizon, and then the upper part is where the moon will be. But 10 degrees actually is not that difficult to achieve. And if you can look out over, say, Vancouver Island, you can even see Mars above the almost mandatory clouds that lie along the ridge of Vancouver Island. So there's a good chance that if the weather is clear, you will be able to see Mars and the moon on December the 2nd at 7 a.m. Okay, so now I'd like to talk a little bit about tides and the moon because of the high tide that's going to be occurring this month. So here we have the Earth, and then way off in the distance off screen, we have the sun. And then we have the moon. And the gravitational effect of the moon and the sun work together to create tides on the Earth. There's a bit of a complication in that the moon goes around in an elliptical orbit. That means sometimes it's close to the Earth and sometimes it's far away. Now this is greatly exaggerated, but it's just to give you the idea. So when is the greatest tidal effect? Well, first of all, it's when the sun and the moon line up. So for instance, these two moons on opposite sides of the Earth will show a large tidal effect because they're lined up with the sun. They would be the new moon and the full moon. Now, when I say the greatest tidal effect, that means the largest swing between high tide and low tide. But on the other hand, if you have the moon's kind of at 90 degree moon pulling at 90 degrees to the sun, then that's when you get the smallest range of tides from low to high. But also there's an additional factor, not as important as the alignment of the sun and the moon, and that's when is the moon closest to the earth. That's the perigee. And of course, when it's farthest away, it's called the apogee. And I've drawn it so that the perigee also happens to line up with the new moon. That's not always true. In fact, that's seldom true. As the months go through the year, the new moon can be at any point on the ellipse of the moon. But it turns out that on December the 4th, it's very close. That is, the new moon is very close to when the moon is also at the perigee. It also turns out that the sun, if the sun is nearer the earth, that would also have a small effect on increasing the tidal range, and that turns out to be January the 4th. So the ideal strongest tides on Earth would be a new moon on January the 4th when the moon is at perigee. I don't know if that's possible, but that would be everything lining up. Okay, so December the 4th, one thing you can do in stellarium is you can not only turn off the atmosphere, so you can see clearly. We're looking straight at the sun, but we can see these stars because we've gotten rid of the glare caused by the atmosphere. And we can even see the moon. And the moon is now at its closest approach, if you will, to lining up with the sun. So this is the new moon. And this turns out to be at 11:30 p.m. So, of course, that's almost midnight. We're looking practically straight down through the earth at the sun when the new moon occurs, the sort of more or less the instant of the new moon. So the moon perigee is on December the 3rd at 11:40 a.m. So that's really close to, that's only 36 hours apart from the new moon, and that's a good enough alignment. So this is when you are going to get the maximum gravitational effect. And of course, that will mean large tides. Now you might wonder, well, where did I find out that the moon perigee was on December the 3rd? And the answer is that I was just skimming through Sky News for November and December, and I was looking at the various features during the month, and it happened to say that the apogee was on a certain date and the perigee was on another date, and I never put that together before, so that's why I've included it in my talk. So here we have the Vancouver tides, and this is the new moon on December the 4th, and here's the full moon on November the 19th. And if you look at the up and down of that blue line, you'll notice that it kind of swings up and down more around that full moon, November the 19th. And also it starts to get larger back and forth near the December the 4th. But the apogee was on November the 20th and the perigee is on December the 3rd. So notice again, you will see that there's a greater range near the December the 4th than there is near November the 19th. It turns out that the maximum tide at Point Atkinson is 16.4 feet. And if you take a look over here, you find that there is a 16.4 foot tide on December the 6th, just after these kind of lining up of the perigee and the new moon. Now, so in one sense, it kind of vindicates this idea that the perigee and the new moon together create the largest tides. But you might wonder, well, wait a second, how come it's December the 6th, a couple of days later? And I don't know all the details, but I do know tides are complicated. There's basically friction, there's the depth of the ocean, there's channels, all of these things conspire to make the to make tides much more complicated than you would suspect. So this is only an the gravitational effect is clear, but the response of the ocean to the gravitational effect is complicated. So that's basically, even if it's a rainy day, you can go down to Porpoise Bay or the Georgia Strait and witness the swing of the tides and say, there, I experienced astronomy today in the pouring rain and the cloud. Okay, so if you have a clear sky on December the 6th at 5:20 p.m., so around supper time, you look up and you'll see the moon and Venus. They'll be, again, pretty low in the southwest sky. New moon, so it's not going to blind you from any of the other sights. And I think Venus here is rather overly large, but it will be bright in the sky. So on a good day, you'll be able to see Venus quite close to the crescent moon. And that's at 10 degrees above the horizon again. So you need a reasonably clear southwest horizon. So that's December the 6th. But actually, this is just something that's going to go over the next 3 days. So you've got 1 in 3 chances of seeing this, or rather three chances of seeing this at least once. So we have Venus, Saturn, and Jupiter kind of all in a line. And on December the 6th, the moon is right next to Venus. And then by December the 7th, it's kind of moved up towards Saturn. And then by December the 8th, it's moved not really close to Jupiter, but it's going to pass Jupiter that day. So December the 6th to the 8th, go out and you have a chance to see an alignment with Venus and the moon, Saturn and the moon, or Jupiter and the moon, 3 chances. Okay. So it's going to be a busy month for the moon, and it's a bright thing, so you don't have to have perfect skies, and that's pretty good for a November date and the kind of weather that we have on the so-called Sunshine Coast. I hope you do have some open skies. Our next meeting will be on December the 10th. And we may meet in the library with a Zoom option for those who prefer not. So we haven't settled that yet. And the COVID situation is fluid, and so is the library situation. So, but we will be getting back to you by email and post whatever news is also on the website, Facebook page. So we hope to see you there. And we have a guest speaker lined up. Charles has already talked about him. So that's all I have to say this month for the sky this month. And again, we hope to see you next month.